Good evening. Welcome back again to this channel. And today we are going to talk about the acid base reactions. Acid base reactions. Now, from our form 1 and our form 2, we usually interact with the acids and bases in their reactions. In form 1, under the acid bases and indicators, we talked about the reactions of these acids and bases, and of course we call this reaction as neutralization reaction. And we see that they are called neutralization reaction because it is the salt and the water which are the only product or products produced, and therefore they are said to be neutral. That's why the reaction is neutralization reaction. And that one simply tells us that acids react with bases to form salt and water only. By neutralization reaction. And neutralization reaction from form 1 and form 2 is a reaction. You can say that it is a reaction where only salt and water are produced, i.e. reaction where only salt and water are produced, i.e. when the acid reacts with a base or metal oxides. Now, these metal oxides, we can talk about calcium oxide, we can talk about magnesium oxide, we can talk about potassium oxide, sodium oxide, lithium oxide, etc. So these are the metal oxides, and these metal oxides are either in group 1, most of them are in group 1 and in group 2, and of course group 1 and group 2 metals, when they dissolve in water, they form an alkaline solution. So that's why we say that these are metal oxides that forms alkaline solutions when dissolved in water, and these alkaline solutions are also called as or known as the bases. So they react with it is a reaction that involves the base and an acid, or an acid and a metal oxide. That is when they dissolve in water, they give an alkaline solution or a basic solution or a basic solution. So, and that is what we call as neutralization reaction. Now, in this case, we're talking about base, and therefore, our equation number one, we will have a look on how sodium hydroxide reacts with hydrochloric acid. This one is aqueous, and also this one is aqueous. So it must have the correct state symbols, and also your equation must be balanced. When sodium hydroxide reacts with hydrochloric acid, we get sodium chloride plus water, H2O, water. Remember we said that it forms a salt and water only. This salt depends on the metal hydroxide we have used, and of course the acid that we have used. So for us to get a specific salt, this one is sodium chloride, which is aqueous, and this one is a liquid. The equation must be balanced. Remember, we have the reactants, and we also have the products. Under the reactants, we have sodium, we have oxygen, we have hydrogen, and we have chlorine. Under the product side, we have sodium, oxygen, hydrogen, and also chlorine. So we can say that our equation is balanced if we have the same ratios on the reactant sides and the product sides. That is the number of atoms present in the reactant side should be equal to the number of atoms present on the product side. Now, under the product side, we have from here up to there, that's the product, the reactants, reactant side. And also you have this one, which is where we have the products. So our first product was sodium chloride, and another one was water. Our first reactant was sodium hydroxide and hydrochloric acid. So sodium here at the reactant side is 1, oxygen is 1, then we have hydrogen is 2, chlorine is 1. When we go to the product side, we have sodium, which has 1 atom, chlorine has 1 atom, we have hydrogen that has 2 atoms, and also have oxygen that has 1 atom. So sodium 1, 1, oxygen 1 and 1, hydrogen 1, that's 2 and 2, chlorine 1 and 1. So we can say that this reaction is balanced. Equation number 2 is that we are supposed to identify the ions that react to give us the respective product. So we are supposed to write an ionic equation. Remember, from the base we get the OH, and also from the acid we have the hydrogen ion, which reacts to give us water. So this one is a liquid, this one is aqueous, and also this one is aqueous. So this is our ionic equation. That is our ionic equation. Now, part B is when we have a metal oxide. So in this case, we have copper 2 oxide that reacts with the sulfuric 6 acid, which gives you copper 2 sulfate, copper 2 sulfate plus water. And this reminds you from two work and from one work that ordinary copper metal does not react with acids, and therefore it is because it is lower in the reactivity series, and it must be reacted with oxygen or burned in a crucible. And you should remember that a crucible is an apparatus that is used to heat substances strongly. So it is copper 2 oxide plus sulfuric 6 acid. Then we get copper 2 sulfate, which is aqueous. This one is a solid, this one is aqueous, and this one is a liquid. Then from it, we are also supposed to write a balanced chemical equation. Of course, it is balanced, considering that we have the product side and the reactant sides. So if it is hydrogen that is likely to be affected, hydrogen here is 2 because of water. And therefore, as to write an ionic equation, remember copper 2 oxide is a solid which reacts with the hydrogen ions, which is aqueous. Then it will give us copper 2 ions plus the water that is obtained. Remember, the rest becomes the spectator ions, and that one simply reminds you on what is the spectator ions. These are ions that do not take part in a chemical reaction. Then another equation number 3, that's part C. This one is aqueous, this one is a liquid, and of course it should be balanced. Of course, yeah, it is balanced. Then we have number 3 is calcium hydroxide, which reacts with nitric 5 acid. It reacts with the nitric 5 acid to give you calcium nitrate plus water. Calcium nitrate plus water, which is H2O. Sorry for this, H2O. Then the equation again should be balanced. We have the reactant sides and we have the product sides. So hydrogen here is 2 plus 2, it is 3. Then here it is 2, so it is less, and therefore if I multiply here by 2, I multiply nitric 5 acid by 2, it means that my water should be multiplied by 2, and my equation will be balanced. This is simply because of the oxygen. The oxygen is the one which will determine our balancing in this case. So this one is aqueous, this one is also aqueous, and this one is a liquid. So from the calcium hydroxide we have the ions that react, which is the OH, which reacts with the hydrogen ions, that will give us water. The rest are spectator ions. Then we balance our equation like that. So our equation can be balanced from the initial equation, That is how we can balance our ionic equation. And also because of water we can balance our equation. That's good. Let's continue. Therefore, we can give an NB because we have realized that it is the hydrogen ion that reacts with the hydroxide ions to form to form water. Then we are supposed to have an NB. Our NB, or what we are supposed to know, is that the hydrogen ion in the acid reacts with the hydroxide ion from the base to form water. That is what we can conclude from our ionic equation. Then we can conclude that the hydrogen ion in the acid reacts with the hydroxide ion from the base to form the water. Thank you. Kindly don't forget to subscribe, like, share, and even comment. I wish you well.